All right, so this one says, they conducted a study of whether running is healthy for men and women. During the first 8 years of the study, 1.5% of the 451 members. Okay, we got some stuff. Let's see if any of these work. So this is 122 in chapter 8. What did I say? 1.5%. 451 members died. Ooh, shit, that took a turn. We are interested in the proportion of people over 50 who ran and died in the same 8-year period. All right. Oh, one thing is, I always forget about this book. This book tries to take away some of my joy. So we use the symbol p hat, right? Because that's what most statistics books and statistics people across the world do. This book wants to use this. They love that little prime symbol. So, screw them. I don't like that. So when they say a little p prime, that's p hat. That's the sample p. Okay. So what part of this are you having trouble with?
Well, I just want to know if I use 1.5 or they change it to this. They change it to decimal.
Hell yeah, definitely. You got to, right? So this is what?
0.0.
And that's what variable?
That's p hat.
That's p hat. Cool. So in this one problem, there are some problems where they do the work for you. You don't have to actually divide. They just tell you what the percentage is from the sample.
Yeah.
So this is one of those. Kicking ass in. What do I check to make sure? All right, first thing. They eventually want me to construct a confidence interval. What equation am I going to use? When they say confidence interval, I'm going to have 3 equations to choose from. And how do I know that they are the confidence interval equations? What's the basic idea of constructing a confidence interval? You have a middle that you calculate, your best guess sample mean, sample percentage, and then how do I make the interval?
Minus or plus.
Yes, you go up and down. So probably the equation I want to use when they say make some kind of confidence interval is going to have a plus or minus in it. Yes. So the 3 we got are this one, the one we just learned about. And the formula tells you when to do which one. And then this bad boy here. So I know it's a confidence interval, so I know it's one of these 3. And it's a confidence interval about a percentage. So yeah, bam. All right. And now that you've identified the formula you want to use, you have to figure out how to get the parts you need, right? So I know what n is. I know what p hat is. I need to figure out q hat. That's easy. And then I need to figure out z, right? Is that right?
Yeah.
Was there another part to that?
No, that was it.
How do I figure out the z-score? They tell you later to make a 97% confidence interval, right? Those bastards. Why is that a gross number? Because if it was 90, 95, or 99, I can get that quick little shortcut baby chart, right? So of course they didn't do that. How do I get the z-score then? Pick a number and hope? Come on, there's a chance. There's a chance. How do you do it? All right, do it. Figure it out. What's the z-score for this situation? Because isn't that the last thing I don't know? For a confidence interval, the z-score always comes from how confident you want to be. Please let this make remarkable amounts of sense. If I have a middle and I want to be 90% confident, or in this case 97, I want to go out far enough so I catch 97% of the data. So then of course I'm 97% confident that I caught a certain thing. No, maybe a little bit. So that's why the Z-score comes from how confident I want to be, because the Z-score is how far out to go. And if I know how confident I want to be, it's going to tell me exactly how far out to go. So how the shit do I find this dude? What does this look like if you draw it? Did anybody draw it? How do I know it looks like this, by the way? What do I have to check?
If it's over 30?
No.
N is bigger than 30.
No. We did talk about this, didn't we? Or maybe we didn't. Where did we leave off last time? No, we got into T-scores last time. We talked about this. We did p-hat stuff, didn't we? We finished this side about... No. The one about voting in the election? No. Not the T-score one. But we finished this one. The one that one side is dolphin links, and the other side was the p-hat problem. I know we finished it because I wouldn't have gone on to the T-scores if we didn't finish this bad one. So don't look at me like I'm crazy. Well, you can't. There's other reasons that I might be crazy. I don't check n greater than 30 because this is not a problem about means. This is a problem about percentages, so my check has to somehow involve percentages.
Times p-hat.
Yes. NP hat and NQ hat. I got to figure out what they are. I am so hopeful that some of you guys realize some of these problems, I don't have to do much work to figure out those. And this problem I do, because I don't know what the number of successes was. They did this work for me, but look, I've got N and I got P hat. Just multiply them. What do you get when you do this? Who to what? Is that 75? No, I'm really pushing that. I don't know if I can do that in my head that quick.
6.7.
Who is it?
6.7.
Oh, all right. I have the decimal in the wrong place. Damn. 6.7. Is that bigger than 5?
Yeah.
Yes, it's at least 5. That's the check. Please don't make this a big deal. We know n greater than 30 is a check. What does n greater than 30 mean for me? For a means problem. It's normal enough. When I have a percentage problem, I still need a check. Why do I need a check? Because I want to use the Z-score chart to figure out what the Z-score is. But what's the only time I can use that chart? If the distribution is normal. So I still need a check. How the shit do I know I can do it? So this is the check. NP hat and NQ hat have to be at least 5. We talked last time about why that makes sense. It just puts the mean in the middle, so it's got room to go up and come back down. That makes almost too much sense. It's so beautiful. I know, I might be a little biased. That's at least 5. And this is definitely going to be at least 5. What's Q hat? What's Q hat?
0.985.
0.985, I like it. So that's going to be 444.3? 0.2, sure. And that's at least 5. So we talked last time about why that check makes sense. And every time you want to do a problem and you want to convert a Z-score from a percentage, you got to know it's normal. Otherwise, you can't do that shit. So there's got to be some way to check to make sure it's normal. Okay, so don't just say n greater than 30 forever. That's only for means. Percentages, the check has to involve the percentages somehow. So now I know I can do something. What does a 97% confidence interval look like? So now I know I can draw this because this worked, so it's normal enough. What does a 97% confidence interval look like? What does mine say? Sweet. 97% confidence interval. Can you do it in the air? There's something you can do in the air that will make you say, oh, okay, somebody did it. I feel a little better. There's 97%, right? Those two lines I drew indicate where what is. What is that I'm trying? What's the only thing I don't know so far? the Z-score. The two lines I just drew are the Z-scores, right? I like it. So how do I find this Z-score right here? Again, I know the chart only understands areas that are below a Z-score. I know I want this Z-score. The chart doesn't understand this. What area is below that Z-score? 0.015. I like it. How the shit did we get that? 97% in, 3% out, 1.5% on that side. You guys with me? Now, please, dear God, notice that it's a complete coincidence, right? I don't even know if I wanted to point that out. That's just a coincidence. Don't freak out about that. Don't make anything big out of that. Can you find the Z-score for this 0.015 area? Do I have a Z-score chart? I don't know, Jeff. You might.
2.17.
What is it? Sorry? 2.17? That sounds reasonable. Anybody else verify that? I thought I brought a Z-score chart, but oh well. Yeah? Okay. We'll go with it. I go with it. Let me stop for a minute. The more you can break a problem down into its various parts, right? The easier everything is. So they asked me to make a confidence interval for a percentage. So already I know I want to use this formula. Then I can start to say, well, what do I not know up here? Z is really the only thing they don't give me. So I want to be able to find it, but in order to find it, I got to make sure it's normal enough. So every step you want to do tells you what you need to check and what to do. So what am I going to put right here now? 2.17. Why do I not care about the negative and shit? Because it's built in. There's the plus and minus. Plus and minus. It's just easier to find the negative one first. Don't put a negative in there and get all freaked out. All right. I think I've done enough of that homework problem for you. You could do the rest of that. Anything else from home? Yes? Number, which one? 153? 23. Thank you. Oh, okay. So the one about the plus or minus 3? Okay. So this is really just kind of like in your own words. Could you explain what error means? So if they get something, point whatever, plus or minus 3%. I don't want to give you an answer because there's multiple different correct answers. And if I say something, everybody's going to write that. But this is really just, do you kind of understand a way to interpret what this piece means? What is that piece? That is what's the name of that piece? Error, right? That's the error piece. That comes from here, right? So that's not good enough. Don't just say, it means the error is 3%. I mean, so you got to go a little further than that. There are a few different ways to say the answer here, but I'm not going to give you one of them. There's also a section of the book that talks about the error. You can go there and get some inspiration. But it really is just, give me some idea of what that means. Okay. And if you're not sure, you can go find out. Anything else from homework stuff? Okay. Let me catch up with you guys. A few more people have come in. Larissa, are you out there? Charlie, Christina? Kaylee? Kaylee. Ah, here we go.
Benjamin.
Anybody else not get their grade sheet back? No? Okay. All right, so, and nothing else from homework stuff? All right, so, a real quick, well, let's finish this bad boy up. I don't remember where we left off. The one that has all the other side. All right. I think we finished number 1, but we had just kind of looked at number 2. Yes? Sure. Anybody else need that with the, yeah. Come back there. No need, please. Oh. Okay. Yes.
I have the Tscore.
Oh, maybe. Let's see. I had a bunch of them. Where did they go? Oh, they're there. Yeah, yeah. All right. Left me with 1. I like it. So, my incredibly condensed lecture about T-scores. I'm not going to ask you that. It's going to say, can anybody tell me why they're invented? Guinness. No. So it's when I don't know the population standard deviation. What can I use instead? When I don't know the population standard deviation, I can use the sample, yes. Sample standard deviation, right? I can always take a sample. So there's this big ass population. I don't know shit about them, and I don't have time to talk to all of them. So I take a sample. The sample standard deviation I get, would anybody put money on it being the same as the population standard deviation? All right, good. Thankfully. I'm not saying it's going to happen. Hey, come over here, I got a game. You want to put some money? No, don't do it, if that's the thing. Right? Because every sample I take is going to have its own variation. So it's really unlikely that they're the same. Which means, if I'm trying to make a confidence interval using a standard deviation I don't have confidence in, you guys with me so far? I have to kind of penalize myself, right? So what we end up doing is making the interval bigger. Yes, maybe?
Cover our ass.
So anybody ever seen that movie, The Fugitive?
Yes.
Good. With the one arm, it wasn't me. It was a one-armed man. And right after it was about a guy wrongfully accused of killing his wife. He's on a bus with all these other prisoners. The bus overturns and they escape. Tommy Lee Jones comes in there and he's like, well, I think it could have been this far. So if he's not sure how fast Tom Hanks' character, I forget his name.
Harrison Ford.
No,
Oh, yeah.
Tom Hanks. Did I just say Tom Hanks?
Yeah.
Harrison Ford. I forget his name in the movie, and I forget his name obviously in real life. If I didn't know how fast he could run, would I make my search area bigger or smaller? Bigger, of course, right? If I didn't know which direction he was going to go, I got to make a bigger circle. So if I don't know how spread out the data could possibly get, if I just have a rough estimate, I have to make my net bigger. So these T-scores are rooted in mathematics, but we're not going to get into where they came from, and you can thank me for that. But the basic idea is they're always a little bigger than the Z-score would have been to cover our ass for something that we don't know. All right, so And maybe also, obviously, the bigger my sample is, the less, now you just read it up. Oh, the less I need the T-Score's help. So the bigger my sample gets, the closer the T-Score gets to the Z-score. Until my sample is freaking large, and then they are just Z-scores. Some of those should look very familiar. They are Z-scores. Because when my sample is big, then I'm pretty sure about my S. I feel pretty good about the standard deviation. We knew this day one, that big sample good, right? Okay, so just to catch us all up on this, let's do this one again real quick just to make sure everybody remembers how this works. We talked about degrees of freedom. I'm not going to do my whole spiel about it again, but it's basically n minus 1. So what's the degrees of freedom on this one? 100. 90% confidence. When I make a confidence interval, how many tails did I just make? 2. And how much percentage would be in the tails for a 90%? 10%. So 10%, let me zoom in a bit. 10% in 2 tails. If you do this, that's 5% in this one tail. You're still in the same column. Do you guys see what I'm saying? So no matter which way you look at it, you should be fine. Although you guys do kind of find a way. Sort of like nature. Students find a way. So on this problem, degrees of freedom is 100. I know I'm looking in this column, so I just stop at 100. There's the T-score I would use, 1.660. So instead of using 1.645, that should definitely sound familiar. We've used that one a few times as a Z-score. I got to cover my ass just a bit. 1.660, a little bit bigger, makes the interval a little bit bigger to cover me because there's a piece of my equation I'm not sure about. You gotta let that be a beautiful idea. I mean, that's just so nice, right? So in this case, 1.660. So we still haven't constructed an interval yet using a T-score. We're gonna get there. The first parts of this are just so you understand how to use the chart. I think we talked a little bit about this. Did we talk about which one of these? Yeah, which one of these can I not do anything for in stats 1? C. Why not? Because it's not normal. Does the sample size save me? No. So, still, to be able to do anything, you have to know that it's normal enough. They either tell you or sample size is bigger than 30, right? And then you could use Z or T. When do I have to use a T-score? When I don't know sigma. T-scores were invented to cover my ass for when I only know S. How am I going to remember that shit? Because the formula's got T and S together. Holy shit, right?
When do I use T? When I know S. When do I use Z? When I know sigma.
So those are notes on your formula sheet because they're formulas and I can't not let you have formulas. So there's a note that sneaks in if you let it be. All right, so let's try these other ones. Sample size isn't big enough here, but why is it okay? I just say it's freaking normal, right? Which score am I going to use, a Z or a T? How do I know it's a Z score? Yeah, which standard deviation do I know? The population one. Now, come on, stay with me now. That's it. Everybody, we talk about this and then people are like, I don't know when to use Z or T. It is that simple. Which standard deviation do you know? Then you can use the right one. If I knew both sigma and S, what am I going to do? Stay with me, because there are some problems in the book like this, and there are problems in real life like this. Sometimes I know the population standard deviation. When I take a sample, can I calculate S? Hell yes. Why would I? I already know the standard deviation of everybody. Of course I'm going to use that bad boy, right? I only have to use T-scores if it's only S that I know. Right? So then somebody always is like, well, why do they tell me what S is in this problem? Because I can always calculate that from a sample. They just told you what it was. We're the people, we're not the problem, we're the humans. We go, that's a nice problem, I know sigma, I'm going to use it. Okay, maybe. So let me see, what's the degrees of, I don't need degrees of freedom, because what is it? Z-score here, Jeff. There you go, buddy. 90% confidence. Can I use my little baby chart? Can you guys look up what the 90%? Beautiful. I could also use this chart. Right? I'm going to find my Z-score and the T-score chart, because where are the Z-scores here? At the bottom. So 90% is the one we were just in. Go all the way down, 1.6 for 5. Bam. So all I'm doing in this number 2 is how far out do I go to ensure that I caught so much percent. And this first one, 90%. What about this one? It says that's not normal. Shit. Why is it still okay? Yeah, and it's greater than 30. So I can do something. What can I do? What do I use? T-score. I like it. So I know I can do something, and the something I can do is use a T-score. What's my degrees of freedom? 38. And I have a 98% confidence interval, confidence level. Take a minute, don't say anything out loud. See if you can look up that T-score. If you can't, you probably want to ask questions. But you're going to have to be able to do this yourself. And just to check in one more time, everybody does have this chart, right? Without this, I'm not sure how you're doing anything right now. So my degrees of freedom was 38. 98% confidence. Which column am I looking in? Yeah, this one. 98% confidence. There's 2% in the two tails. And I'm going to stop at 38. So the idea is if I stop, I get a T-score. If I go all the way down, I get a Z-score. I like it. So this is the one I want, 2.429. C is the one we identified as can't do. It's not normal. Sample size doesn't save me. Too bad. D is the one I could do doubly, right? That's bigger than 30, and it's already normal. Shit, I'm good to go both ways. Which score am I going to use on that one? T, because I only know S. What's my degrees of freedom? I can't help but say it that way, I'm sorry. You can take my dignity, but you can't take away my degrees of freedom. 99% confident. So take a minute, again, make sure you can find that T-score before I do it with you. You can always choose to sit there and be angry at the world too. That's always an option. So what do we got here? 99%, which column am I going to look in? Yeah, the first one. 1% outside. And then I want to stop at 60. Sure. 2.660. I like that. I would. Earlier we had a 1.660. And now we got a 2.660. Make that look more like an O, Jeff. Make that look more like a 6, buddy. There you go, man. Yes.
Oh, I don't know.
Okay.
No, because I feel like, didn't we already do this?
I don't think we finished this section.
Oh.
Yeah.
I already had it done on my paper.
Oh, sweet. All right. We're catching up to you. I'm sorry. So now number 3. Finally, we're going to do something. You guys are going to do something. Anybody need to borrow a copy? All right, now, all right.
Yeah, the higher it is, yeah. So this is bigger.
So guys, is this a sample or a population I'm working with? Because it says sample, right? So just look for that. So when you put this into your list, you know which standard deviation to use, which means it tells you why I'm going to use a T-score. Why am I able to do anything? I've only got 7 grades. I've only got 7 grades. How am I able to do anything? No. There's no percentages here. N is less than 30. It says it's normal. Yeah. Right? So you know you've got a C. Does it say it's normal? If not, is the sample size big enough to save my ass? In this case, I don't need the sample size to save my ass. It's already normal to start with. All right, so put those in. See what you get for X bar and S. Stay with me now. And then part B, the only thing you have to figure out is the T-score that goes along with the 98%. So let's try this. We're finally doing it all together. Just make sure, let's see. Has everybody got that in there? Have you calculated? What are you guys getting for your X bar?
78.29.
I like it. Become a 9. And what are you getting for your S?
15.72.